All right, we are ready to go. Welcome everybody to episode 2 of Hack Summer. My name is Michael Taggart, or just Taggart, and we're here talking about Python and cybersecurity. You can find me on Twitter at mttaggart. And as I said, we're doing Python, we're doing cybersecurity. The last time that we were together in our first episode, we covered the basics of the Python programming language. We learned our first instructions and we became Python programmers. We started with two of the 4 core concepts, the core structures in programming. We started with variables. So as a recap, variables are how we store information inside of a named entity in Python, so we can reference it later rather than having to rewrite the same thing over and over again. We also experimented with conditional statements: if, else, if, elif, else. And so using those, we came up with a conditional greeting depending on what name we read in from input for our program. So we had a very good first session. We kind of got our feet wet with Python, but it's time to go a little bit deeper and time to do some more interesting things. As I mentioned, there are 4 core structures in programming, and we've covered 2 of them: variables and conditionals. The third, which we're going to be talking about today, is loops. Now, there are a couple of different ways of describing loops, and we'll get into them in just a minute. The most important thing to know about loops is that it's a way of repeating code as many times as we need so that we don't have to write out the same code again and again. But before we get into that, I wanted to take just a minute for our new programmers to talk a little bit about going from where we are to where you want to go. Now, I don't know what got you interested in programming. Maybe you're just experimenting with it and you're not really sure if you like it yet. That's totally fine. Maybe you really want to be a software developer. Maybe it looks like a good career for you. Maybe you like the idea of being able to write code. Whatever the reason, you hopefully have some end goal in mind, even if it's just knowing it for yourself. And when people start on the programming journey, it really seems like a very steep uphill, especially because if you think about the software that we use every day, right? All of the applications that we use, games that we play, all of the different software that we are surrounded by in our lives, it seems impossible that the little bit of code that we're writing right now at the start can eventually translate into that. That's a really difficult thing to conceptualize. So I just wanted to talk for a minute about that journey of getting from just writing hello world all the way to developing the application that you want to develop or achieving the career that you want to achieve. We are absolutely just getting started. If you just started programming with us last week, you've been doing this for a week. If you've been doing other sorts of programming for a little bit, but you're still kind of a beginner, that's totally fine. The truth is that there are many different skills that go into being a software developer or a programmer, and programming is just one of them. There are lots of other pieces that go along with writing code: project management, communication skills, organizational skills. And even when it comes down to just the software, there are all other kinds of tools besides just the code that we use as software developers to develop applications. We haven't even touched on developing user interfaces or managing how we package up our software and ship it out. All of that is way down the line. So I just wanted to address this idea that what we're doing right now seems really, really simplistic, and it doesn't seem like it is going to immediately translate into creating an application the way that you're used to thinking of software. That's okay. We're going to get there eventually. But for now, what I really want to focus on, 2 things. The first is the logic and the structure of computer programming. That's kind of where our foundation is going to be laid. The second thing, because of the theme of this course and my own career, is we're going to be focusing on security and how to do things in a safe and secure way so that when we do build software, we're thinking about how it can be protected from unexpected uses. All right. With that out of the way, we have a lot to cover today, so I think it's time to get into some code. All right, so we're going to switch over to our coding window here. And if you were here last time, we're using Replit or REPL.it as our programming interface. Oh, that's cool. So glad that happened. Okay, let's try that again. All right, so we're using Replit because it's an online platform for delivering code interfaces, and it's usable with many different languages. We're going to be using it with Python, but it's a great tool to explore many different kinds of computer programming. When we get a little bit further along in our programming experience, we will switch over to using a different tool if we can. But for now, because Replit is free and everyone can use it, I wanted to start here. So just in case you hadn't joined us last time for this. Okay, so I'm logged out in case you're logged out, just to show you how our login process goes. If you need to sign up, go ahead and click sign up. Otherwise, go ahead and click login and go ahead and log in with your credentials. I'm going to log in with my Google account and away we go. I'm going to go into my REPLs here just because I like having things organized. And we'll start here with a new REPL. We're going to choose Python as the language, and it makes a random name. I'm going to change up my name to something else. So I'm going to change mine up to login 1. All right, and create REPL. All right, and I'm going to zoom this in a little bit just so it's a little bit easier for us to read together. All right. Now we're going to start, before we get to loops, we're going to start with creating a login system, sort of what we talked about last time, where we have a password, we need to test user input to see if it matches the password and determine whether the login was successful or not. We're not going to check for username as well. We're going to keep it simple and then we'll build on from there. Okay, so first thing we're going to do is let's get a quick tour here of the interface in case we're all new, or in case somebody here is new to Replit. So we have our files that we're working with on the left-hand side. Main.py is the one that Replit makes for us. And in Replit, main.py is is the code file that's going to execute when we click run. And that can be a little bit confusing if we have other files that we're using. Main.py is the one that gets run no matter what. So just a heads up on that. And for that reason, we're going to be making, rather than kind of making a bunch of different files in one Replit, we're going to be making multiple Replits or REPLs for our different pieces of today's project. Okay, so we have main.py. This is where we write our code. Over on the right-hand side, we have the Python interpreter, which is where we can write single lines of Python code to test it. So for example, if I write print hello world, I get that. I can do some math over here too. But this is also where output from our written code, our program over here, is going to show up. So it kind of serves two purposes. All right, so building on what we did last time, we're going to create a login system using a conditional. Just a conditional right now. We haven't gotten into loops. We're just going to make a login system. And we're going to use good programming practice, and we're going to entitle our code here with a multi-line comment, which we put inside of triple quotes. Non-simple login system error. All right, so that's all it's going to do, is it checks for a correct password. Now remember, comments are not interpreted by the Python interpreter as code. So if you have comments inside of these triple quotes for multi-line comments or after a hashtag like this, the Python interpreter will not execute that as code. It's just for humans. All right, so we're going to make a simple login system. The idea is that we are going to have a password. We're going to ask the username to enter their password, and we're going to check whether the two match. Simple enough. The first thing we're going to need is a real password. Now, I'm going to make a new variable to contain that information. I want to make it clear that this is a really bad idea in programming practice in general. We're doing it now for demonstration, but in a real program, we would never store a password inside the code like this, okay? So I want to call out a couple of things here just as I'm writing this variable name. You'll notice that it's in all caps. That is because it's a constant. We don't expect the data in this variable to change. That's not a rule. You don't have to do it, but it's a styling convention that we use as Python programmers. So if we have I could have made it as real_password. I could have made it real password like this. I could have made it real and capitalized the P, which is what we call camel case. Python doesn't care. The language itself doesn't care about how I name my variable, as long as there are no spaces inside of it, right? Real password wouldn't have worked because it's two different words. Python cares about white space. But other than that, there are no rules about how we make variables, but it's really, really important to know what the stylistic expectations are. It's just like writing, right? We have some things that we do that are stylistic, that are expected. So when we have a variable that doesn't change, we all caps it to indicate that it's a constant. You'll also notice that I put an underscore between two words. In some languages, we capitalize the second word of a two-word variable name. That's called camel case. We do that in JavaScript, for example. And some Python programmers do this, but the more accepted style is to put an underscore between them. So just know that. You'll see me do that a bunch of times during today's and future lessons. So we have a real password variable. We're going to set it to something. Now, you can set it to whatever you want. I'm going to set it to secret password. Now, I did this wrong. I have a mistake in my code already. I wanted to see if anybody could catch it. If I'm AVV, if you remember that, I'm assigning a value to a variable with a single equal sign. I'm assigning to the variable real password the text secret password. What do I need around secret password in order to make it appropriate? If you said quotes, you are absolutely on the money. So remember that we have strings. Strings are a kind of information in Python, and that is absolutely what secret password is. So we need to surround this with quotes. Notice I could do that by just highlighting the text and typing a quote. You can use single quotes or double quotes. I like to use double quotes. I think that's because I used to be an English teacher. But anyway, all right, so we've got ourselves a real password. Now, we're going to ask the user to enter a password. To do that, if you remember, we use the input function built into Python. Right? We can say input, what's the password? Or you could, whatever message you wanted here. Input takes a string inside its parentheses, which is going to be the prompt for the user to enter data. Now, this input command is correct, but unfortunately, the data from it isn't getting stored anywhere yet. So I need to, once again, assign that value to a variable, and I'll call that test password. And I am lowercasing that because I'm expecting that value to change. It's not a constant. And again, I'm using the underscore because it's two words. Some programmers use really, really short names for their variable names. I don't like doing that because I want my code to be readable, as readable as possible and understandable as possible just because of the way I've written the code. Okay, so we have our real password. We're asking for our test password. We can run our program right now. Nothing will be asked for the password. What's the password? Test. Nothing happens because we haven't done the check yet. The next thing that we need to do is we need to compare the two things. That word is really important. Comparisons are really important in Python. So you may remember from last time that we were able to do some inequality comparisons. We did 3 is greater than 2, which returns a value of true. True is a kind of data, just like 3 is an integer and secret password is a string. True is a Boolean data type, right? We have true and false. And we can test, so we can also say 3 is greater than or equal to 3, right? That's how we would do that one. And we can also do comparisons for equivalence, right? 3 equals 3. Check this out, 3 equals, in quotes, 3 is false. So it's also checking against data types, right? So an integer is not equal to a string. Okay, so we're going to use this double equal sign. And it's, again, remember, it's a double equal sign because we already have a meaning for a single equal sign in Python, to compare test password to real password. And if they match, we're going to do something special. Good question. Do we always need an extra space between the operators? So I want to make sure I'm being clear here. So you'll notice that I have a space between these two sides of a comparison or an assignation. No. So if I did like 3 no space double equals 3, that works just fine, but that's not as readable. So by convention, we put spaces between them, but it's not necessary. Good question. Where we definitely want to avoid spaces is if we're doing a greater than or equal sign. So if I do 3 greater than or equals 3, that's going to work. But if I do this, that's wrong. That's 2 different operations. Let's say 3 greater than, and then something is assigned to 3. That doesn't work. Okay. All right, so we have this comparison, test password equals real password. Now this right here is going to evaluate to either true or false. It's going to become something. So we have to test for its truth or falsity. We do that with if. And then we put a colon, and then on the next line, an indented, we're going to do whatever we want to do if that test is true. For this case, we're just going to print login successful. Yeah, that's the right number of C's and S's in there. And if it doesn't work, if it's not true, else print login failed. So just a few reminders on our syntax here for the conditionals. Okay, so we have the if, the test that we're conducting, which has to be something that evaluates to true or false. If the test returns true, we're going to do what comes right underneath and indented beneath the if. We can have an else statement attached to it to say this is what we want to do if it fails. And then we could also have an elif in here as well for a second condition, and we can chain as many elifs as we want. Right now, we're just going to do, the password is right or wrong. So let's go ahead and run this and see what happens. So what's the password? I'll just put in some nonsense here. Login failed. And the program ends. So keep that in mind. All right, so let's try another one. What's the password? Well, let's try the right one this time, secret password. Login successful. All right, so our conditional is working. So we're well on our way. That's good news. But we can do better. What are some things that, when you think about a login system, what are some features that exist as you're attempting to log into a system? So one that I think about a lot is the kind of the tries, the lockouts. So definitely input validation, Eddie. Really good question, right? Like we have to make sure that the input coming in is not garbage. And that actually is an attack vector depending on our input validation, which we'll get to a little bit later in the summer. But yeah, so one feature that is definitely when I think about login systems is maybe a lockout, right? If we have X number of fails, we just stop trying. And so we're going to try to do that in our next version of this. We're going to try to do 3 tries and then you're done. Okay. So, and we're going to do it with only tools that we have already. We're not going to introduce anything new yet to prove a point. Okay, so we're going to click on new REPL. And yep, Python. And I'm going to make this login 2. Okay. And real quick, you could have copied and pasted, and I probably should have from our last project. So we're going to do basically the same thing we did before, but with a certain number of tries. So we're going to do again real password equals secret password. You can get more creative than that. We'll talk a little bit about good passwords. And so now we're going to add our test password, right? We're going to get input from the user. Again, notice I'm putting that space at the end of the prompt here, just to make it a little bit easier for the user to read. Okay. Now comes the part that's really weird. So we're going to do the test. We're going to do if, same thing, test password equals real password, print login successful. Now, this is the part that's going to be a little bit different. We're going to do else print incorrect password, not login failed. And there's a reason for that. Okay. We're going to modify this password prompt string a little bit. We're going to put in the number of tries. And again, if this seems a little contrived, it's to prove a point. So now we don't yet have any way of repeating sections of code. We're going to get there, but just with the tools that we have, how would we give the user 3 tries? Copy pasta. Two out of 3, and then down here 3 out of 3. And then at the very bottom, we'll do one more check for test password, right, to see if the login actually failed. So if test password, let's actually switch it up. Rather than seeing if they match this time, let's see if they don't match. Because by the time we get down here, right, we've gotten our 3 tries. So the exclamation point, which is often pronounced as bang in programming, so bang equals real password, is not equal to. Okay. We're going to do print login failed. So here, after 3 tries, if the password doesn't match, we're going to do login failed. All right. So let's see here. What's the password? 1 of 3. Test. Let me in. And we get login failed. 3 attempts. Everything's good. Okay. And then, of course, if we were to run it at any point, so let's try, so test, and then the second attempt, we do secret password. Login successful. Oh no, right, we're still gonna get the password. So I actually need to run sys.exit in here to stop that loop, or to stop that from happening. Right, because what happened was, even though it was correct here, it went on to the next bit of code. Right. To do that, exit isn't a thing yet, so we can't just do that. So what we'd have to do is, just for the purposes of getting this to work, this was really just a demo to prove why we don't do it this way, but if we wanted to make it actually quit, import sys, and then after login successful, you would do sys.exit. But don't worry too much about that. I didn't want to introduce this just yet, but that's how it would actually work appropriately, so that it doesn't give us as many tries as we need, or more tries than we need, rather. But the point I want to make is that this sucks, right? This is not a good way of doing this. First of all, it breaks a really cardinal rule of programming. That cardinal rule is DRY. Not yield, DRY. Don't repeat yourself. Programmers are lazy, and whenever we have an opportunity to not repeat ourselves, we're going to take it. So obviously we're repeating ourselves way too much here, right? Look at all of this. We're writing the same string over and over. That's no good. We've got the same conditional going over and over again. That's no good. We can do better. And the way that we're going to do better is with something called a loop. All right. So let's go ahead and make a new REPL just from here. This was just to demo why we don't do this. And let's try this one more time. And we'll go ahead and make login 3. Okay, let's talk about loops very quickly. So loops are a way they're ways to repeat code sections. Okay, if you think about the way that our programs have been running, right? They've been going top to bottom. And when we have a conditional statement, sometimes they change course a little bit, right? They'll take different paths. Loops and conditionals are part of what we call flow control, meaning that they alter the top to bottom flow of a program's execution. So with loops, we can repeat sections of code a given number of times, or until a condition is no longer met. In Python, we have two kinds of loops. We have the while loop, and we have the for loop. We're going to cover both of them, but we're going to start with the while loop. A while loop will repeat sections of code while a condition is true. Let's try a very simple example. Whiles are interesting also because they often require an external counter. So let's try a counter. So we'll just count up to 10 with a while loop. So we'll just make a very simple variable of n equals 0. Okay, and then while n is less than or equal to 10, we'll print n, and we will n equals n plus 1. So we're changing a variable value this time, right? We're saying now n is equal to whatever n currently was, and then add 1 to it. Okay, so a couple of things to notice. So while the while syntax is very similar to the if syntax. So we've got while, a condition that we're testing that has to be true or false, a colon, and then an indent. And then the stuff inside the indentation is going to repeat again and again and again as long as this condition is true. So let's see what happens when we run it. I made a really silly mistake. Who caught it? I inverted the inequality. There we go. So while n is less than or equal to 10, it prints out all our stuff. And notice that it's changing our value of n. By the way, there's a shortcut syntax for this n equals n plus 1 that you're going to see over and over again, so I wanted to take this quick opportunity to introduce it. We can do the same thing with n plus equals 1. Okay, that works exactly the same. We're saying now increment n by 1. If you're coming from other languages, you may have seen something like n++. That doesn't work in Python, but plus equals 1 works fine. Okay, so we have the while loop, and that's what we're going to start with here. Let's think about how we would implement our login system with a while loop. The first thing we're going to do is we're going to say, let's make our real password again. And we're going to also set up our maximum number of tries, or maximum number of attempts. And I'm going to set mine to 3. And then I'm also going to create a variable that's lowercase because this one's going to change, right? Tries equals 0. Okay, so we're going to want to do the same thing we were doing before, testing the password and asking for the password. We're going to do that as long as the number of tries has not exceeded or matched the maximum number of tries, because we're starting at 0. So we're going to start with a while tries, which we're going to be changing inside the loop, is less than max tries. As long as that's true, we're going to keep asking for the password. We'll do the same thing. We'll just do test password equals input. What's the password? And if you wanted to, you could get even fancier with this. You could do something like what's the password, and then plus, and then you could do some string concatenation to add the number of tries in there. For now, we'll leave this as is, just to keep it a little bit simpler. Okay, and then we do our conditional test, right? If test password equals real password, we're going to print login successful. Now we have one more thing that we need to do when the login is successful here. Remember how we had to do that sys.exit to get out of the program? Well, we don't have to do that this time because we just need to exit out of the loop. So when we need to get out of a loop early, we have a keyword to do that, and that is break. So this will quit the loop even if the conditional is not false. So if the login is successful, we don't need to keep trying. We're going to just get out of here. That's it. Okay. Otherwise, we're going to print incorrect password. And we also, in this particular case, have to increment the number of tries. Tries plus equals 1. Okay. Because we have this handy test, right? If we get to the end of the loop we can test the password again, or we can just say if tries, not tires, equals max tries. If it got to that number, we can print, sorry, about the Fast and Furious movie getting filmed somewhere outside my building. Login failed. Okay, so let's just take a look again at what we have here. We have a while loop that's going to repeat all of this code as long as this condition is true. And every time through the loop, we are making the test, we're asking for input, and we are incrementing tries by 1 if the password was wrong. If we got it right, we just quit. And we don't quit out of the whole program, right? We break out of the loop, which means the program jumps down to here, line 24, which is why we have to test for that tries equals max tries, because we don't want it to print login failed if the login was successful. Okay, what's the password? Well, let's just try. Okay, so login successful works, and I definitely forgot to put that space after the string for the input. What's the password? Let's get it wrong this time. Test. Come on, let me in. So we get our 3 tries, and then after 3 tries, login failed. All right. Any questions on our while loop? This is a very simple implementation of an authentication system. Real ones would be a little bit more complex, but it's a good introduction to the while loop and why we use it. While loops are great when we know, not necessarily, in this case, we know how many times we want it to repeat, but more importantly, we know the condition under which we want the repetition to happen. The next kind of loop is even better for times when we just have an X number of times. We have an idea how many times we want something to repeat, and it's not conditional, it's just a certain number of times. Or repeating over a set of things that we have. So before we move on, let's just quick check any questions on the while loop. Yeah. Well, all right then. As I said, we have a lot to cover today, and so we've made good headway. The next thing we're going to cover is the for loop. And the way that we're going to do this is we're going to make a very simple password generator. So before we dive in, I wanted to talk a little bit about password strength and why it matters so much. We're going to demonstrate a little bit of that here today. What are some rules that we know about password strength? You can put them in the chat or just think about them. Things that you've heard or rules that you've had to follow when you're creating new passwords. You may have heard things like use special characters. It has to be a certain length. Don't use common words, right? There are all sorts of rules for password hygiene, but really, really important, I think, for today's conversation is length, and then the variation in the kinds of characters that you're allowed to use. The reason is when the bad guys are trying to crack your password, they have to do something either what's called a brute force attack or a dictionary attack. With a brute force attack, They're just like literally going through a certain number of characters, right, and testing everything in the alphabet or everything in the alphabet plus numbers plus special symbols. So the more things that you mix in there and the longer your password is, the longer it will take a computer to try to crack that, to run tests against your password. And it might seem simple, but the length in terms of complexity for the computer program is exponential. And so when you have a really long password, it would take a computer an unreasonably long amount of time to try to guess it. Dictionary attacks are where we have a list of words, and we try to use, if they're common words, we'll try to use list of words to guess your password, which is why it's really important to not have common words as your password. Even phrases made of just common words without anything special. So those are two things that we want to think about when we think about password strength. And we're going to play a little bit with that today with the rest of our session. Okay. So the first thing we're going to do is we're going to make a very, very simple, too simple password generator. But we're going to do that to prove a point and to learn the other kind of loop, the for loop. All right, so we're going to make a new REPL, and let's call it make pass one. All right. What we're going to do in this piece of code, this program, is we're going to use just the lowercase alphabet. We can make it more complex, but just to start, we're going to use just the lowercase English alphabet to generate a random password of a given length. And to do that, we need a couple of things. The first thing that we need is the random module inside of Python. Before we got to loops, when we were just creating repetitions of our code and we had to use sys.exit to get out of our program, you saw me use the import keyword with sys. Import will add functionality from other Python modules into our program. So for this one, I need Python's random module. To see what it does, let's say import random over here in our Python shell. And let's try random dot, is it just random? Will just give me this? Yeah. So random.random will just give me a below 1 decimal number at random. It's technically not random because it's still a computer, but it's what we call pseudo-random. Okay, it's not as natural as tossing dice, but it works for our purposes. We also have random.randint, which will give us, if I give it like 1 to 6, will give us an integer in that range. Useful for simulating dice rolls. So we need random because we're going to be making a random choice out of a string. The other thing that we need is a for loop because we're going to be looping over certain things. So let's talk about for loops. A for loop will repeat code over an iterable. What is an iterable? An iterable is a kind of data in Python that can be broken down into smaller pieces. So, for example, a string is an iterable. Let's try that out. Let's make our alphabet. That should be all caps because it's a constant. Did I get that right? Nope. Almost. QRST. Yeah, all right. Now, let's experiment with the for loop syntax. We'll say for L in alphabet, print L. So this is a little bit different than the while loop syntax. For, and then we create a temporary variable. That's why it's so small. You could call it 4-letter, you could call it whatever you want, but by convention, they're very tiny. This variable is called an iterator. It's keeping track of where we are in the iterable or the sequence that we can loop over. And then in, and then we list the iterable that we're going to loop over. Make some predictions about what you think this is going to do, and then go ahead and run it. Okay. There it is. We looped over the string, which is alphabet, and we got every letter in turn. So what we want to do is we actually want to create a random password out of this alphabet, and we want to do it for a certain length, whatever our length is. So let's ask the user for it. Okay, let's say pass length, and we'll ask the user how long, or let's just real short, password length. Okay. And then this, we need a number here. And so one kind of complicated piece of a for loop for Python is that when we need to loop over a certain number of times, we need to use something called a range. And just over here real quick in the right-hand side, let me show you what range does. If I do range, not ranty, range of 10, that's so annoying. It doesn't show it to me anymore. Thanks, Python 3.8. Let me quick turn it into a list so you can see what it is. Actually, you know what? Even easier. Let me just do a for loop for I in range 10, print I. Oh, for the love of God. There we go. Okay, so range gives us this piece of data in Python that contains the integers up to but not including that number. Really, really, really helpful if we're trying to keep track of where we are. I like to think of range as Python counting on its fingers. You ever do that? You ever count on your fingers so that you know where you are? That's what Python's doing when we're doing something like this. So we're going to use whatever this pass length is as our range. And so we're going to change this up a little bit. Very commonly, you'll see for I in, and I is just short for iterator. I in range pass length. What do we want to do? Well, we want to make a new string. We want to make a new password. So what we're actually going to do here is outside of the loop, we're going to start that variable, password equals, with an empty string. We're going to start it empty and then add to it over the course of the loop. What are we going to add to it? Remember that we can add things with the plus operator, even to strings. Right? Remember string concatenation. If we do A plus B, right, we get AB. So we can use the plus operator. When we're adding to an existing value, just like we did with the counter for the while loop, we can do plus equals. So password plus equals. What are we going to add? We're going to do, this is a really fun trick, random.choice, and then notice the documentation, choose a random element from a non-empty sequence. All right, well, what's that non-empty sequence that we're going to use? Alphabet. Okay. And then at the very end, we'll print the password. Outside of the loop, notice. right? Because we have to loop through that first and then we'll print it. Now, keen-eyed observers will probably suspect that this will fail, but it's really useful to find out how it's going to fail. All right, password length, let's do 8. And indeed it failed. This is a Python error message that I see way too often, especially from students. I guess not too often from students. It's okay to make mistakes, but it's one that can be prevented by thinking very carefully about data types. And when I say data types, we've discussed them kind of on the edges. Strings, integers, decimal numbers, which we call floats, booleans, true and false. Whenever we're programming, we have to be thinking about what data types we're working with. And if we mix them up, we're going to run into some problems. And that's what's happened here. So let's take a look at this error message. The error gives us a traceback telling us where exactly in our code the error occurred. So it happened in main.py. Yeah, we know. Line 15. Okay, well, that's interesting. What's going on line 15? Okay, for I in range past length, it says type error. Str or string cannot be interpreted as an integer. What? Okay, so what are we using here? We're using pass length. Where did that come from? Pass length came from input. If you remember from last time, everything that comes in from input is a string, which means we have to convert it into an integer before we can use it this way. The good news is that there's a really easy way to do that. Check this out. If I use int as a function and then give it a string that looks like an integer, it'll turn it into a number. So what we're going to do is in range, and then we're going to wrap this pass length inside of an int and some parentheses. We could have also done that up here. We could have wrapped this in an int as well. But now this should work. Let's go ahead and try it. Password length, 8. Awesome. Let's run it again. Let's try for 12. Cool. Guess what? You can add whatever you want to this alphabet and it'll still work. If I wanted to add special characters, now I have special characters that I can get a random choice from. Whatever I put inside of this string will be an option for random.choice. So I can absolutely use it there. Okay. We're running a little short on time, but there's something really cool that I want to do with you guys. So, should not say you guys. My apologies for that. Something cool I really want to do with y'all, which is I want to get to the password cracking. So we'll try to squeeze that in. If we go a little bit over the hour, I hope that's okay. It'll be, if you can't stay until you can't stay after, that's fine. The recording will be up. So we're going to make a new REPL, but before we do that, let's just real quick copy all this because we're going to use most of this code again. Okay. Let's go ahead and do make pass 2. Now this time, what we're going to do is instead of printing out the password, or just printing out the password, we're also going to write it to a file. Okay, so we're going to learn how to do that. We're going to learn how to write to files. We do the same thing. For the purposes of what we're going to do for our guesser, I know this might seem a little bit contrived, but we're actually going to reduce our alphabet here to just digits. Okay? I know that seems a little bit silly, but as I said, password strength really matters. And to make this a faster demonstration for the kind of compute time that we have, it's going to be really helpful to do that. Okay. So we have our alphabet, which is a little bit less complex than it was before. We have our password length. We're going to set this kind of statically to 5 for right now. You can keep the input if you want and just enter 5 every time, but I'm going to change this up to set it to just 5. So we don't need the int in this anymore if we do it that way, because we're not converting a string to an integer. And let's see what the difference this makes. Okay, so it's a terrible password, but we're doing this for a reason. The piece that I want to teach now is we're going to write this to a file. So in addition to printing the password, we're going to learn how to write to files. We're going to use open, and open will open a file, and depending on the mode that we open it in, it can either read or write. It can either add to a file or kind of overwrite what is in a file. So we're going to open password.txt, comma, because this time we have to give it 2 pieces of information, W, which is the write mode. So open password.txt in quotes, comma, outside the quotes, W in quotes, and paren. And then we're going to assign this to a variable, call it pw file. And then pw file has some abilities, some methods. Dot write, and then we're going to write the password to it. And then just for hygiene, we close the file with pw file.close. So we open the file with write mode, so we can send stuff to it. We write the password to it, and then close it. And then we'll print the password to our output. Let's go ahead and run that and see what happens. Oh snap, look at that. We got a new text file inside of our directory. And if we look at it, there's the password. Because we wrote it, we opened the file in W mode, it's going to overwrite the password every time we run it. So if we run it again, a different password is going to be in there. Okay. Last piece here, for the last kind of operation that we want to do is learn how to read files. And this is where we're going to transition from generating passwords to guessing passwords. So here's what I'd like you to do. I'd like you to, whatever random password, you can run it as many times as you want, whatever random password you got here, I'd like you to take that password.txt and copy that text. Okay, Control C, Command C. You can also download the file if you wanted to. But for now, let's just copy that text and make a new REPL. We'll call it guessPass1. And inside of this project, we're going to add a new file. We're going to call it password.txt. And we're going to paste in whatever that value was. Okay. Now, we want to guess the password here. Obviously, we have access to it, but that's not the point. What we're doing is demonstrating how we would guess a password. And then later in the course, we'll actually use a brute forcer against a real web application that we'll throw login attempts at. But for now, the first thing that we need to do is get access to that password data inside the file. Now, Obviously, we could have just added it as a variable in here, but that's not the point. We want to read the file. So we do the same kind of thing that we did before, pw file equals open, but this time we're going to leave off that w, password.txt. We're going to leave off that extra part with the comma and w because we're opening it in read-only mode. We don't need to write to that file. Okay, so we're just opening it and getting the information. And then we'll say the real password equals pw file dot, and then again, that file has some abilities. Anything with the parentheses after that is a function, which we'll talk about later, but is something the file object can do. So we want read line, and that's going to be text, and we want it to be a number. So again, we're going to just intify that whole thing. We're going to wrap all that in an integer conversion. So we're opening the file, we're grabbing the text, we're converting it into an integer because we know that we need it as an integer. And then just to keep things clean, we close the file. All right, it's 11 o'clock. I'm going to keep going just to finish this up. We have one more piece to do. It shouldn't take too long, so if you can stick around, please stick around. But if you can't, that's okay. Feel free to watch the recording afterward. We'll definitely make sure that the edited version of the stream is up and available. Okay. So we're going to start at 0 and just test for the number. And this is why we want it to be a short number. Test pw equals 0. We're going to add 1 to the test pw and keep checking it against the real password to see if they match. How would we do that? Well, we need to loop. We don't know how many times we have to loop. And whenever we don't know how many times, but we know when we want to stop, that's a while loop. So we're going to do while test pw. When do we want to stop? We want to stop when the test password equals the real password. So as long as they don't equal, we're going to keep going. Right? Remember that bang equals is when this is not equal to this. We'll print it out just to see it go because it's pretty cool. And then test pw, we're going to add 1 plus equals 1. Okay. I'm quite confident that we're going to find the password. So at the end of this, we're going to hit password found. We're going to print password found. And I'm actually going to do a trick here. Print can take multiple arguments. So rather than doing some string concatenation here, I'm actually going to just do comma and then the test pw, which will print out both of those on the same line. All right, ready? Let's go. I think that's cool. And mine even had a 9 at the beginning of it. So it was like almost the worst case scenario for a five digit, or a 4-digit number. Now notice that mine had a 0 in front of it, right? So that is one shortcoming that we have here. Let me change this up to 7 or a 4, right? And let's run it again just to see what happens. Takes a little bit longer, but it works. Now this is obviously super contrived, right? Because in a real password cracker, we would need to decrypt the password first, or attempt to decrypt it, or encrypt the guess. But we'll get to all of that. But the point I want to drive home is we're opening a file. We're running a repeated sequence of code over and over again with, in this case, a while loop before we were doing a for loop to generate the password. And we're conducting tests each time. And look how fast it was able to guess it. But if we were to add just a couple more digits to this, right? Let's just add one more digit to it. You can see how much longer it takes, right? Look at it go. This really puts it in perspective how much password length matters to your security, because look how long it's taking to try to guess this thing. It has to go through all of these. Replit might even yell at me because I'm using too much of its computing power to do this, right? People who do this professionally, they have pretty serious machines on which they crack passwords. They use the same kind of equipment, interestingly, that you would use to mine a cryptocurrency. So if you want Bitcoin, or if you're done with Bitcoin and you still have the equipment, you can crack passwords. All right. Last piece for today. For this one, we're going to need to get another file. So go ahead and let's make a new REPL. We'll call it guesspass2. And before we write any code, we're going to make a bad password file. Call it badpass.txt. And inside the bad password file, we're going to write let me in. Just like that. There's a reason for that. What we're going to do this time is a dictionary attack. What we just did was a brute force attack. This time we're going to do a dictionary attack. To do a dictionary attack, we need a dictionary. We need a list of words that we're going to test against. To do that, we're going to go out to the internet and get something from one of my favorite lists of passwords. So what I'd like you to do is search for sec lists in Google, or whatever your search engine preference is. Search for sec lists. The first thing that should come up is Daniel Miessler's sec lists repository on GitHub. And that's what I'd like you to go to. Okay. Seclists is this amazing repository of data that we use in the cybersecurity industry, both offensively and defensively. We can use it to attack both websites and login portals, things like that. You can see that there's usernames, there's potential web access, indicators of compromise, and we're going to go into passwords, and then go into common credentials, and then one of the lists is best 1050, and I'd like you to click on the best 1050, and then just go ahead and click on raw. So we have the raw text. Look at this thing. Okay, this is a pretty cool dictionary. So, by the way, this stream is not marked for students because there are definitely some bad words in here. So just be aware of that. That's going to happen. It's the internet. Know how to handle it responsibly. So we're going to copy this list, and we're going to make a new file here. You can call it dictionary.txt if you want. And we're going to paste it. Okay. There's our text file. There's our dictionary. So we have a bad password. We're going to try to guess it with our dictionary. Here's how we're going to do it. We're going to start by opening our dictionary file and getting all of the words in the dictionary. Open dictionary.txt. I can spell dictionary.txt. Now, dictionary itself is going to be dictionary file dot read, not read line like we did before, but read lines, which gets all of them. Now, read lines itself is going to give us what's called an iterable, right? We talked about iterables, things you can loop over, and it's going to be one per line. Make sure you have those parentheses there. And then go ahead and close that file. All right, now we need the bad password. And you can name your variables differently from me. That's totally fine. I'm just doing it for clarity. So I'm going to open badpass.txt, again, only in read-only mode. And then badpass equals badpass file dot read line, same way that we did before. And then again, we're going to do badpass file dot close. There's another way of doing this without all the open and close. Well, you still need the open, but you don't have to explicitly do the close, and we'll cover that in later times or later sessions. All right, we're almost there. Thanks for those of you who are sticking around. I really appreciate it. Now, we need to quickly modify the bad pass because there's a line break at the end of it, which we want to get rid of. So we're going to say badpass.strip because the line break, the return, doesn't help us at all. So we're getting rid of that line break. Strip just takes off line breaks from the end of lines when we read them from files. Okay, now we want to go through every password in this dictionary, and we want to test it against the bad password to see if they match. To do that, rather than use a while loop, we're going to use a for loop. For p in dictionary, we're going to say test pw equals p, and again we're going to use that strip just to get rid of any line breaks in the line, just to make sure that we're just testing the text. Right, when we have a long file, right, there's a line break at the end of every one of these lines that's recognized as part of the line, and we don't want to deal with it. Okay, we're going to print that test just so we have some cool output, and then we're going to test. We're going to compare the two. If the test pw equals bad pass, we're going to print found and use that comma, right? Test pw. And then we don't have to keep looping anymore, right? We're done. Once we found it, we're donezo. So we hit break. Break works with for loops as well as with while loops. That'll stop the loop, and that's our program. Okay, so we're looping through every password in our bad password, or our password dictionary. We are taking the line breaks out of each line just so we don't have to worry about them. And we are testing it against our bad password. And sure enough, it went through a whole bunch of these, right? And by the time it got to L, we found let me in, and it found it. Okay, we have finished our code for today. Let's just quickly wrap up, and then we can be on our way. I really hope that this was valuable to you. I hope you enjoyed it. I had a lot of fun going through this. I think that the security parts of password strength is a great way to learn the while loop and the for loop, and you can see how fundamental they are to all kinds of code that we use both in cybersecurity and other kinds of programming. I also hope it's clear why password strength is something that we security folks are harping on all the time. First of all, I want it to be clear that you're not as clever as you think you are. If you really want to have an interesting time, go take a look at that SecLists repository and look at all of the different dictionaries of passwords that we have at our disposal. And this is like the basic list, right? Some of those lists are millions of entries long. So you may not be as clever as you think you are when you're, substituting, numbers for letters and things like that. Those are tricks that are known. And it only takes one breached password to gain access to a system. So for your own security, I hope that you use strong passwords. They should be long. They should be reasonably complex. I like passphrases. So uncommon words put together in an unlikely sequence. Those are great because they're easier to type. And okay, so that's kind of what we needed to talk about for password strength and for our while loops and for loops for today. We'll obviously be doing a lot more with while loops and for loops in our coming weeks. Thank you for joining us. Thank you for staying a little bit over. If you are enjoying what you're seeing here and you feel like giving back a little bit, I encourage you to donate, not to me, but to an organization that seeks to bridge the digital divide, giving much needed technology and low-cost internet connections to families in need, and that's Human IT. They're a great organization. They're a well-regarded nonprofit. If you feel like contributing back because of the value you're getting from this program, please feel free or feel like you can go to humanit.org to donate. Next week, we are going to be thinking a little bit more about those iterables that we've talked about, and we're going to be getting into a really important data type inside of Python, which are lists, right? How to have multiple entries inside of a single variable. I'm really excited to do that. Thank you so much for joining us here at Hack Summer. I hope you had a great time. We'll see you next week.